Hello everyone, I'm Albert. Welcome to Hands-on FPGA Design, from Theory to Implementation. In this course, we'll be using the Vivado software suite. My goal is to help those of you interested in ZedBoard development get up to speed as quickly as possible. I'm part of the Intelligent Vision System Design Lab, iVSLAB, led by Professor Jiun-In at National Yang-Ming Chiao-Tung University. You can find our lab website link in the bottom right corner. Before we dive into the core lessons, I'll cover some essential FPGA background and show you how to download Vivado. First, let's take a look at the front and back of the ZedBoard. This clip here demonstrates an LED counter we implemented. By toggling the switches on the far right, you can control the counting speed. Also, notice that when I press the button, the counter resets. Our curriculum consists of 8 hands-on tutorials. We'll start by getting familiar with the interface, then move on to lighting up your first LED. Later, you'll learn how to create IP modules and eventually design a complete system. That's the overview. Let's get started. What is an FPGA? FPGA stands for Field Programmable Gate Array. Field. This means the chip doesn't need to be sent back to a factory. Anyone can modify it anytime right at their desk via a computer connection. Programmable. It's incredibly flexible because you define the chip's logic by writing Verilog code. Gate array. Think of the internal structure as countless unassembled Lego bricks waiting for you to build them into whatever you want. Now that we know what an FPGA is, let's explore some of its applications. Currently, FPGAs provide low latency technology for 5G signal processing. In terms of data acceleration, they outperform CPUs for specific data tasks. We also see them in real-time video encoding. Looking ahead, edge AI and hardware accelerators are the big trends. For example, our lab researches self-driving systems integrated with LiDAR technology. FPGA also play a vital role in the upcoming 6G era and low Earth orbit (LEO) satellite networks. Next up, PS and PL, which stand for Processing System and Programmable Logic. PS, Processing System. This is the CPU region. It runs the operating system, handles various programming languages, and controls the overall system flow. PL, Programmable Logic. This is the FPGA region responsible for high-speed parallel computing and real-time execution. SoC, System on Chip. When you package both PS and PL into a single chip, like the Zinc 7000 on our ZedBoard, you get an SoC, which achieves perfect hardware-software co-design. Moving on to the ZedBoard's hardware layout. The board on the right is the ZedBoard we'll be using. Let's do a quick tour. Here is the power jack. Here are 8 LEDs with their corresponding switches and buttons for user control. The heart of this board is the Zinc 7000 SoC chip right in the center. With its rich interfaces and excellent scalability, it's a perfect choice for both beginners and pro developers. Now, let's get to know the development tools, Vivado and Vitis. Vivado is an integrated design environment, IDE, primarily used for PL design. You can think of it as drawing the hardware blueprint. The flow goes like this. Step 1, create a block design. Step 2, write your Verilog code. Step 3, synthesize it into a logic circuit, as shown in the diagram. Finally, generate a bitstream file to burn the design into the ZedBoard. Once we export the XSA file from Vivado, we move to Vitis. Vitis is used to write code for the PS side. The flow goes like this. We'll begin with creating a platform based on the XSA. Next, we'll dive into developing your C++ code, and we'll finish with executing and debugging the program on the CPU. Moving on, I'll demonstrate the downloading process for Vivado and board files. I've placed the download links in the video description below. To begin, open the first link to the AMD website. Select version 2020.2 and download the installer. Run xsetup.exe. Click Next. Select Vitis, which includes Vivado. Agree to the terms. Choose your directory and start the installation. Next, we're going to open the second link to download board files. Scroll down to the third point and download the files. Open the new folder and copy all 28 files inside. Go to your File Explorer and find your Xilinx installation folder. Xilinx, Vivado, version, data, boards, board files. Paste the copied files here. Now, Vivado will officially recognize the ZedBoard. In our next lesson, we'll start our first lab, controlling LEDs using both switches and buttons. I'm Albert. Thanks for watching, and I'll see you in the next class.